As humanity seeks to return to the moon after half a century, space agencies worldwide are in need of a substantial amount of lunar soil, and lots of it. John Gruener is a space scientist within the Astromaterials Research and Exploration Science Division at NASA. Breaks down why and how this type of soil will put humans back on the moon, along with his love for space farming. Join us as we get rebelliously curious. John, thank you so much for joining me on Rebelliously Curious today. So this is going to be a wordy one. You work at the Astromaterials Research Exploration Science Division at NASA's Johnson Space Center. So
yes, that's right.
Yeah. Can you tell us a little bit about what that position entails, please?
Okay. Well, this division has its roots going all the way back to Apollo, because when the astronauts went to the moon, they also brought back samples of the moon. And people realized, oh, we're going to need a place to house those samples and protect those samples. And so our division, kind of formed out of that. And then over, more than 50 years now that we've been a division, we have a lot more than just the Apollo samples. We have meteorites from all over, including the moon, but also Mars. We have cosmic dust. We have solar wind. So we're kind of the curators of most things that people happen to have in the solar system. That's why we have that general term called Astromaterials, because it's not just the moon, it's not just Mars. It's as much as we can get from the solar system, right, to try to understand it better.
Yeah, it's amazing. And right now, recently, you guys have been working on, it's making fake moon dust. Yes. So it's a simulant. And so can you tell us a little bit about making fake moon dust? And then I know it's called a simulant, but then what's the difference between simulant and soil and real actual soil? But let's start off first with why is NASA making fake moon dust?
Okay. So we just talked about the samples that came back from Apollo, but there was only, so much, about 380 kilograms of rocks and soil. And of course, that was a national treasure. It was a world treasure. And scientists are still looking at those Apollo samples and making new discoveries today. So it's, it's really precious. But now we're talking about Artemis and going back to the moon. And we have tool developers that want to develop, new geology hammers or chisels. We have new spacesuits being developed, so we want to know how the fabrics are going to resist abrasion. But there's just not enough of that real Apollo material to go around for testing purposes. So that's why, and this isn't the first time this has happened. Lunar simulants have been around since about the 1980s. For the very first reason, very same reason where, people were talking about going back to the moon again, but this time to stay, and we're going to live and work there and process the natural resources. Well, there was no way that Apollo sample could cover all of that. So we find rocks and soils here on the Earth that are similar to what we found. And I say we, and I'll probably say this a lot today, right? But I was a little kid in elementary school when NASA went to the moon with Apollo. And I watched it on television and I was fascinated, and here I am working at NASA. So, if I refer to Apollo as we, that's the greater we as in NASA, right? But back in the 1980s, when people started talking about going back to the moon again, but, in a big way and using the natural resources, we needed to have something to test technologies in. Whether you're going to dig up on the moon or chemically process the moon or use the soil on the moon to make a structure, right? We needed to provide a simulant. And so the very first simulant that was created was called JSC-1. And it was a simulant based on those dark regions of the moon. You look up at the moon at night, you see bright areas, you see dark areas. Most of the Apollo landing sites are in the dark areas. And those are just basaltic lava flows. So the same thing we watch come out of the ground in Hawaii, right? In other places on the earth. You know, anytime you see Iceland right now, a lot of tourists go to Iceland and watch this basalt come out of the ground. They're a little closer than I would be. But so that very first simulant was made out of basaltic material from the state of Arizona, because it happened to match some of the chemical and mineralogical characteristics of what was found at Apollo 14. And a critical thing is it wasn't just the minerals and the chemicals, it had glass in it. It was the feedstock for that simulant was basaltic cinders that were exploded into the air out of a small volcano, or we call them cinder cones, but it was exploded in the air. And so some of that magma that was coming up quenched and turned into glass. And so it turns out the soil on the moon is both crystalline material, rocks and minerals, but also glass material from impacts, billions and billions of years of impacts. So that those cinders in Arizona were a great first start into lunar simulants, but we ran out of it, right? And so there have been ebbs and flows in the lunar simulant world, right, where we have plenty and then we don't have any more. Maybe the countries aren't talking about going to the moon anymore, so we don't need lunar simulant anymore, right? But now we're talking about Artemis and going to the south pole of the moon. And that's one of those bright areas when you look up at the moon at night, right? The south pole is just like those bright areas of the moon, unlike the dark areas. So it's a very feldspar rich material. And those rocks are harder to find on the Earth. But there are some places, and we are making simulants out of that. And so this whole idea of, is it soil? Is it, dirt? Is it,
Well, yeah. What is a simulant? Because we know that it would be artificial. So is it synthetic, or are we taking oil? Oil. Are we taking soil samples from other regions, like you said in Arizona, and then are we going back into a lab and making this kind of synthetic version of a lunar soil? Like, what's the process? Yeah.
Okay, so the process is the first step is just like you say, you go find geologic feedstock. So these are terrestrial rocks and soils. And we do this for Mars as well, right? We have Mars simulants. But right now with Artemis, we're all focused on the south pole of the moon. So we have to create a highland simulant. And so we go and we look for these geologic deposits where this certain kind of rock called a northocite is. And there aren't a lot of these places. And right now in the States, we get a northocite from Montana. In Canada, there's a place to get a northocite from. It's called the Chalmers northocite, and it's not too far from Toronto area. It's further north. And then recently we've been working with the northocites from Greenland. That's not too far from North America, right? So we have to go to these places and get rocks. And then we bring the rocks back to the labs, and now you turn the rocks into, I joke about this, and I'm sorry, I'm going to joke a lot because scientifically, right, this is lunar simulant. Well, that sounds very technical, but we can't really recreate the moon as well as we would like, right? We don't even come close to maybe 80% similar. Maybe it's even 75 or 70%, So I always jokingly refer to it as fake moon dirt, right? Just to remind people we're doing the best we can with terrestrial rocks and soils, but because of the environment of the moon where there's no atmosphere, there's no life, there's no water, those rocks and minerals form in a completely different environment than they do here on the Earth, where of course we have water everywhere and we're teeming with life, right? So within the rocks that are somewhat lunar-like, there's also minerals in there that are non-lunar-like, right? So it's just depending on how technical you need to be for your specific project. But once we go out and we collect these rocks or soils or cinders, different size particles from, big basketball-sized things down to sand, right? We bring them into the lab. Typically, we crush them into smaller and smaller particles, and then we match what we call the particle size distribution. So when they brought the soil samples back from Apollo, and they did call them soil samples, right? But the scientific term that we use for that covering on the moon is regolith.
Right.
That just confuses everybody, right? That we don't just always
Rock
say
and
soil.
regolith. Right.
But there's this term called regolith, and it's just this unconsolidated loose cover or blanket all over the moon, and it's very, very tiny dust particles down in the single microns, all the way up to boulders as big as houses, right? So regolith covers a large range of material, right? And so a lot of people like to use that word soil because it's not so much the big stuff anymore, right? And most of our simulants are 1 centimeter or less particles. And then it's kind of like a baking recipe where you need a certain amount of this size particle and then a certain amount of smaller particle and a certain amount of even smaller particle, right? We use sieves to separate the different size particles after we've crushed the rocks. And then once we have those different particle sizes, we mix them together to try to match the particle size distribution on the moon and tumble it and blend it. And then we have a simulant. So we started with rocks. We wind up with something that's very much like cat litter. And, and then it just depends on you. Are you trying to develop something to work on the dark parts of the moon or the bright parts of the moon? So you could either have a basaltic, Mare simulant or the bright feldspathic highland simulant. So we have a little of both, but everybody's really interested in the South Pole. So we're all about feldspathic highland simulants these days.
That's really exciting. And so for these simulants that you're creating, it's for, testing machinery, but it's also then looking at potentially growing some type of plant or something. We know that in China, and I believe that it was actually just a couple of years ago that they ended up growing a first kind of seedling on the moon. Can you talk to me a little bit about that if you're familiar with what happened in China? And is NASA doing anything similar as a similar program? Because I thought that was really exciting when I saw that. I know it only lasted a couple days and it kind of turned into this, it looked like it turned into this jelly-like form, but at least it was the beginning of something.
Yeah, I'm not familiar with that exact experiment. Is that something that happened on the surface of the moon on one of their missions?
Yeah, it was. And I'm going to look at the date right now. It was in
Okay.
2019. They said the first seedling to sprout on the moon. Yeah.
Okay, so 2019, maybe that was the Chang'e 4 mission. Yeah, China is doing great on the moon. Their Chang'e series, 1 and 2, Chang'e 1, Chang'e 2, were orbiters, but then starting with Chang'e 3, they started going down to the surface. And both Chang'e 3 and Chang'e 4 were twins. They were very similar in mission, stature and components. They both had rovers. They called their rovers U2. Very successful, really good data on the ground penetrating radar to tell us what it's like below the surface. Really good data on some of the mineralogy and chemistry. And then their latest mission was Chang'e 5 that actually returned samples back to the Earth. And that hadn't happened since the early 1970s with the Soviet robotic Luna missions provided samples from the moon, after our Apollo human missions did. So China's doing a lot of interesting stuff on the moon. They have Chang'e 6, which will head to the moon in, I think, a year or two, land on the far side of the moon,
Right.
and return samples from the far side. Now, we think we do have samples from the far side in lunar meteorite collections. A lot of people don't realize there are lunar meteorites, all over the Earth, and there's over 300 of them now that have been discovered. And you look at the chemistry and the mineralogy, and you compare them to what was brought back from Apollo, and you know that these rocks came from somewhere else on the moon, not in the Apollo region, right? And so this first sample return from the far side will be quite interesting when it does happen with Chang'e 6. So as a simulant person, we go to all the lunar science conferences and meetings because, in order to make better simulants, we need to keep up with lunar science. So we read what the Chinese found with Chang'e 5. We read about the new lunar meteorites that have been discovered and what people think about them. And then we try to incorporate that into our lunar simulants.
It's awesome. I want to go back to potential like agriculture on the moon. I'm
Mhm.
so fascinated by it. Like where is NASA with that and that type of research? Because I know the simulant's really important, obviously, to grow anything that's agricultural based. But where are we with that? Are we looking at doing that hopefully sometime in the near future?
Um, uh, Possibly, right? So at NASA, we had an Artemis 3 science definition team that came together to kind of define the types of science we would like to do on Artemis 3. But it also, part of that was also, well, Artemis 3 is going to be somewhat of a constrained mission as far as capability goes. But later Artemis missions, where we have a base camp and laboratory facilities, the Biological and Physical Sciences Division at NASA headquarters, they're very interested in, growing plants in the lunar regolith to see how it works, how it doesn't work. And so, as a matter of fact, we're just getting ready. They put out a proposal or a call, right, for people to send in proposals to grow plants in actual lunar soil from our division here. But to start off, they're going to have to grow plants in lunar simulant and show how, what they're doing and how it worked with lunar simulants. And if they made good progress and passed a certain bar or a level of whatever the biological and physical sciences division is looking for, then they can apply to get lunar soil to grow plants in. Because there was a recent paper on somebody who did grow plants in lunar simulant and lunar soil. They got a small amount of lunar soil to do that. And of course, if we're really going to be there for a long, long period of time on the moon, right? For a long period of time with quite a few people, we're going to have to grow food there because that supply chain from the Earth to the moon is fraught with peril, from launches that have to work to spacecraft that can't get lost on the way to the moon, and then landing that has to all work perfectly, right? And so you get all of your food and air and water that way. It would be much better if we could live off of the land, just like humans have done on the earth forever and ever. And so the challenge, of course, is there's nothing organic on the moon, and an organic component of the soil here on the earth is very important for growing plants, right? So we're starting from zero as far as organic content. So, that's one thing the plant people will have to work on. And I should say here, back in the 1990s, I was a space farmer. That was for about 10 years. I worked on a project in bioregenerative life support systems, where we were growing plants in life support systems, and those plants would give us oxygen, right, through photosynthesis. They'd give us water through transpiration, and then they'd also give us food to eat, right? And that was going to be for space station. But then space station decided to go with an open loop life support system where all the groceries were just brought up on rockets and resupply vehicles. Air, food, and water, goes up to space station every 3 months or so. And so they didn't need the advanced regenerative life support system, and with budgets the way they always are in the space program, so that project was kind of stopped. But there are bits and pieces of regenerative life support system up on the station right now, recycling human, sweat and urine to make water. There are small plant growth chambers up on ISS right now, growing plants, and most of that is being run out of the Kennedy Space Center in Florida. I always had to remind people back when I was a space farmer that I'm just a simple dirt guy. If you really want to know about the plants, go talk to the plant people, right? But we work very closely together to get plants growing in closed life support systems. And we were talking about China earlier. They have a fabulous facility called Lunar Palace 1, where it's very similar to what we were doing back in the 90s, which we're not doing right now currently. But they have an enclosed, set of modules and chambers. They have people that go and live inside this enclosed life support system, and there's plants growing in their life support system. So it's really neat. Like I said, it's called Lunar Palace 1. You can find that online somewhere, and that's what we were doing. But not since the decision for International Space Station to go open life support, but as Artemis matures and we get away or we get beyond the first missions of 6 or 7 days, and we start staying there for months and months, this whole idea of regenerative life support system is going to come back because it is so important. And so one of the challenges with using that lunar soil is, a lot of those plant essential nutrients that we have here on Earth. I don't know if you do plants or gardening, but when you buy a bag of fertilizer, there's three big numbers on the front of that fertilizer bag or can, right? And that's nitrogen, phosphorus, and potassium, because those are so important for plant growth, just as oxygen, carbon, and hydrogen are, right?
Oh,
But of
yeah.
course, plants can get their carbon, oxygen, and hydrogen from humans, right? We breathe out carbon dioxide. Um, we drink water. We need water. So if the water is going to be there to support the astronauts, the water will be there for plant growth as well. So those six major elements are critical for plant growth. But then there's a whole host of secondary elements like calcium and magnesium and sulfur, and then the micronutrients, like iron and copper and zinc. All of those things are on the moon waiting for us, but not quite in the amounts that they are here on Earth. So, I always tell people it's going to be a multiple step process where we're going to have to dig up the soil. And this applies to Mars as well, right? The soils on Mars someday will be growing food for people. But you dig up the soil and then you have to remediate any kind of problems that you may encounter. Those dark areas on the moon that we talked about earlier, the Mare regions. So there's chromium in that soil, right? So heavy metals, which we really don't want our plant roots taking up and then us eating the plants with heavy metal in them, right? So fortunately, the highlands on the moon aren't going to have as much of those toxic type chemicals in them like the Mare soils. So we're
Right.
starting with great soil in those bright areas of the moon, right? But after we've remediated whatever we need to out of them, then we're going to have to augment them with chemical fertilizers for a while. When you're growing your first tomato plants and you pluck the red tomatoes off and you say, oh, it's so great to have a fresh tomato on the moon. Well, that green plant you're not going to eat, but you're going to cut it up and you're going to compost it and you're going to put it in the soil and you're going to start building up that organic content slowly but surely, right? And just like farmers here on the earth, a lot of people think farmers' number one job is to produce food, whether it's milk or it's crops, right? Their real most important job is to continually improve your soil, because if you deplete your soil, you can't produce food for either you or for your animals, right? And so building up a soil on the moon and then continually improving that soil on the moon with composting and other techniques is going to be so critical someday, right? But at first it's going to be experimentation, and we'll bring fertilizers with us to the moon. Maybe it's hydroponics on the moon at first, but it's going to be a long process, and I won't be around in the space program to actually participate that because I'm not too many years away from retirement. But the kids following me, right? They're going to be the ones. There's going to be kids that are going to, that's going to be their job, right? How do we grow food on the moon? Because it's
They're
going to be so.
legitly going to be space farmers. Like
There will be.
legitly.
Yeah.
Yeah.
I was just like I'm a purveyor of fake moon dirt. I was
Right.
a fake space farmer because all my farming was done here at the Johnson Space Center in controlled environments where our life support system technology was being developed.
That's amazing. I am a fan of rocks, moon rocks. If you look in the corner over here, I'm going to move my camera. I have in a little box, that shadow box,
Oh
are
yeah.
moon rocks and all of those different things. I really love them, from craters to you name it. And I'm slowly like collecting them and making my own kind of like artifacts and a section of all the different things. So I think it's really exciting. And also just the fact of like the whole space farming. Like I think when we go to space and when we're on the moon and all the different types of variety of plants that will hopefully potentially going to grow and what the soils are going to represent and what they're going to grow in them and what they're going to look like is I think really, really exciting.
Yeah. So in
So
about
I'm
a
going to be a
year,
lot older, I assume, when that happens as well too. So
but in about a year from now or so, there should be some more scientific papers coming out about the NASA Biological and Physical Sciences divisions, plant growth uh,
wow.
experiments, and yeah, more and more people, will start doing this. When that movie The Martian came out, I don't know if you
Right.
saw that movie,
I
right?
did, yeah.
Just about every soil science department in the United States decided they wanted to grow food in Mars simulants, right? Just like the movie. Let's see if we can do it, just like the movie, right? And
Science
it's gonna,
fiction always, science will always follow science fiction to a degree. So I'm not surprised. That makes me
yeah.
happy
So
too.
I hope
Yeah.
the same thing happens on, with the moon. That
Yeah.
as we spend more time up there on the moon and more nations are on the moon, right? That more people are, oh yeah, how would you grow stuff on the moon? And there are companies out there that will sell you lunar simulants, right? As a matter of fact, in those old days, I was telling you about the JSC-1 with the original simulant. Simulants back then were created by NASA, right? Now, most of our simulants are created by commercial outfits. Now, two of them happen to be from universities, so I don't know that they're really commercial. I know they're trying to, just get their cost paid for. But we here in the States, we have Exolith Lab at the University of Central Florida. We have Colorado School of Mines. And then we have a real private company in Everett, Washington called Off Planet Research. And all three of those groups are making and selling lunar simulants for people to use for all purposes, right?
That's amazing. I actually going to order some and I'll just put a little package in a little container in there because who wouldn't want a lunar simulator? I think it's great from private companies. And I was going to ask you that too. There are multiple private companies and there are companies around the world that are developing these stimulants, not just let's say NASA. I would imagine that there's some kind of competition that's happening at some point.
Yeah, I'm not sure how it works in other countries, right? But I know the European Space Agency, ESA, is
Right.
working on its own lunar simulants. Uh, the Chinese are working on their own lunar simulants. Japan and their space agency, JAXA, is working on their own lunar simulants because you can imagine crushed rock is kind of heavy, so it's expensive to ship. And if you need large amounts of it, you know, here in the States, we're not going to, buy simulant from Europe or Asia because the shipping is just going to be so expensive. So everybody's, looking for local geologic resources in their countries or in their regions, and then making simulants out of that, right? And so in that BBC article that you read, right, they started with some small group working on a simulant there on the islands off the coast of, I guess, Portugal or so. And so, using local stuff is a lot easier. Right there in Canada, I talked about the Shawmere and Northa site. There was a company called Deltion, and they made a lunar simulant called OB1A. And it was a great physical simulant. It was about 60% crystalline and northocite, but then they put 40% glass into it. So it was a really good physical, very abrasive simulant. So if you're worried about your little hinge working out on the surface of the moon, or if you're worried about your spacesuit material getting abraded away, that was kind of like a simulant of choice. And Deltion is no longer in business, but I never can remember their name, but it's a company called MDA. And so MDA is a Canadian company, and they now have the rights to make OB1A simulant. I don't know that they're doing it yet, but Canada is getting more and more involved with the lunar exploration, particularly in robotic rovers and things like that, right? So Canada is going to need more lunar simulants. And of course, they can just get it from south of the border from the companies or the universities in the US. But there's always some pride in being able to make lunar simulant in your own country.
No, I'd imagine so. Everybody has their own type of lunar like simulant. I think that
Yeah.
it's your pride and joy of your soil, and then you could see potentially what you'd be growing somewhere out in space. How much how much lunar simulant does it take then for you to practice, or I guess the word would be practice, on how machines would work potentially? Like how much are you using to use as as an experiment?
Okay, so that's a great question. So I'm going to show you this. This is
Nice.
just like a little coffee can size thing. And this is JSC1, right? And this is about 1 kilogram. This is about what 1 kilogram of lunar cement looks like. Most of the technologies that people are working on, particularly in a field they call dust mitigation, where this dusty, gritty material is going to get into everything. Just like if you take a vacation to the beach, right? And you leave your sandwich out too long, windblown sand starts getting in your sandwich. And then when you bite your sandwich, it's gritty, right? So it's going to be like that on the moon. So, but if you're just trying to test a joint or some type of bearing in a wheel that's going around and around, right? You don't really need a lot. And most of the projects that we work with and provide simulant to, it's usually 5 kilograms or less. We'll
Oh,
do them just fine. Now, if you're trying to design a rover, right, that's going to drive around a large area, or if you're trying to design a drill to drill down into the subsurface, or an excavator to dig up the surface, now you need more and more simulants, right? And those people typically need on the order, measured in tons. We're not talking kilograms anymore. We're talking metric tons. And some facilities, like there's a granular mechanics lab at the Kennedy Space Center. For fun, it's called Swamp Works, because of all the gators in the swamps down there. But at Swamp Works, they have a facility that has like 50 or 60 tons of lunar simulant in it, right? And so, the larger device you're trying to build or test, the larger facility you need to do that testing in, and hence the more simulant you need. So at NASA, we have projects that can get by with a few kilograms. We have projects that need a few 100 kilograms, and we have projects that need, a few tens of metric tons. So that's really challenging because it's expensive. To take rocks, crush it, and then put it in the right particle size distribution, and make sure you have glass and all those components that we've talked about early. It's hard to do, and it's hard to do correctly, right? And so it gets expensive when you try to acquire lots and lots of it. So it's always a challenge keeping a budget line item in your project for lunar simulant, um, particularly if you're doing excavation and you happen to need 10 tons of it, right? But luckily there's different fidelities of simulant. So there's higher fidelity simulant that is more like the lunar soil, right? And then there's lower fidelity simulant where maybe it's not close to the lunar soil, but for your purposes, it'll work just fine. And so those lower fidelity simulants, like JSC1, you can get those basaltic cinders from Flagstaff, crush it into powder, and now you have a pretty low fidelity simulant because it already has the glass in it, and that's great. Well, with the glass, it's not quite low fidelity. But the point is, you can buy simulants that aren't as intricate or complicated cheaper than you can some of the more complicated simulants. So we have a range of fidelities in our simulants: low, medium, high, and that's one of the things we do in our project, the simulant project. We will talk with the other technology projects to get an understanding of, what are you doing with this simulant? Is it just physical interaction with it? Are you chemically processing it? And then how far advanced is your technology? At NASA, we have something called the Technology Readiness Level, or TRL, where 0 is just a concept in your mind, and 9 is space flight. It's been in space, it worked, it's proven. So now it's this technology is TRL-9 and it works in space, right? Well, most projects, when they start out, are kind of in that TRL 2, 3 range, right? So they don't need the best lunar simulant around to test their concepts at TRL 2 or 3. But when you start getting up to TRLs 5 and 6 and 7, you need to graduate to better, more expensive simulants. But hopefully you've worked out all the details of your technology with your simulant, lower fidelity, cheaper simulants first, and you do your final testing in smaller amounts of the more expensive simulant. So we work with a lot of different projects. We have meetings like this where we're talking to them, they're showing us what they're doing, and then we'll give them recommendations on simulants. And it's kind of like going to the automotive repair shop or something. You go in and they say, oh, well, this one's easy. It's only going to cost you $100. And you always go, whew. So when we tell people, yeah, you can get by with a pretty simple simulant, not very expensive, and that makes them happy. The people that are chemically processing the simulant to separate the oxygen from the soil, from the metals in the soil, like if we're ever going to do production and construction on the moon, we're going to separate metals from oxygen. And now you're chemically processing the soil. The fidelity of that simulant jumps really high, right? So people trying to chemically process the soil need to know that we can get by with these lower fidelity simulants for a while, but eventually we're going to have to buy some expensive high fidelity simulants for you to get higher up on that TRL scale so we can get you into space and with confidence that it's going to work on the moon.
Are there any environmental or health concerns while doing this type of research?
Not so much environmental, effects, because it's like any place where you have, rock crushers crushing rock to make the components for concrete, so we can have roads and buildings, right? But there is health concerns that we always talk about with people, predominantly something called silicosis, where the silica, quartz, cristobalite, things like that, can get into your lungs. And if enough of it gets in there over a long enough period of time, you can develop this problem called silicosis, right? So we have what we call personal protective equipment, or PPE. Mm-hmm. And when you work with simulants in the lab or in a chamber, everybody is mostly wearing, you're protecting your lungs. You're mostly protecting your lungs with the PPE, right? The simulant itself is just like dust and dirt and grit that we have, when we go camping or we go to the beach. And it's irritating sometimes. Maybe it dries your skin out, but it's not it's more a nuisance than a health concern. But breathing in the dust from the silicate minerals, right, that make up our simulants, that's a problem. And so we work with a lot of people on the proper PPE so that they are working and testing in simulants in a safe way.
Thank you so much, John. After this, I'm going to go buy some of my lunar soil simulant and put it with my rock collection up there. Thank you so much for spending time with me.
Make sure you get some dark stuff and some bright stuff, right?
I will. I'll have the contrast, right?
Yeah, the whole moon right there on your shelf.
Right, exactly. Thank you so much, John. And as I say to all of my guests, thank you so much for being rebelliously curious with me today.
Oh, yeah, this is fun.